Hey, ChemStars, this is Mrs. Vadeway bringing you homework this time. All right, I'm bringing you a ChemStar video. This is page 9 and 10, the very last two pages of your Chapter 9 homework packet. And so we are just going to go over this. Now, I've written, you should have already completed this. You're supposed to do this on your own. And now you should be checking your work. All right, so you're not just copying down your answers, you're checking to see if your already done work is correct. If you need, get out your periodic table and your calculator so that you can maybe follow along if you didn't get what I got. So here we go. So this homework, we're going to be calculating theoretical yield, actual yield, and percent yield, and there's our equation again. So let's start with a decomposition problem. Let's decompose some sugar. All right, we're gonna add some yeast and we're gonna make some ethanol, which is this, and then some carbon dioxide. All right, well, what's the first thing I have to do? Balance it. All right, when I balanced it, I'm looking at it and I have carbon, 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 oxygen, oxygen, oxygen. So when I approach this, I balance the hydrogens first. So if I have 12 hydrogens and 6 hydrogens, I put a 2 here. All right. Now let's look at the carbons. I have 6 carbons here. I have 4 here. How many do I need here? I need 2 more carbons. And voila, what do you notice? That the oxygens are already balanced. All right, so letter A says, what is the mass of ethanol, that's your C2H6O, is made from 55 grams of your sugar. All right, so here, this box kind of telling you what to do. You have to convert your grams to moles. So how many moles is 55 grams? Periodic table, and I got 180.18. I did 12 carbons, so 6 times 12.01 plus 12 times 1.01 plus 6 times 16. That's where I got that. And I put 1 mole on top, right? So what happens? My grams cancels out, and I got 0.305 moles. I hope you did too. So what do I do with that? Well, that's this. What else can I say immediately before I do anything else? I have 0 of this to start with, oops, and I have 0 of that to start with, right? So I only have 1 reactant, so it's not really too difficult here. So I'm going to subtract that full amount. And do you remember how I get these numbers? I take 0.305 divided by 1 times 2. All right. So 0 plus 0.710 is 0.0710. I did the same thing. What's 0.305 divided by 1 times 2? I got the exact same thing. All right. And so there I go. Well, what is the mass of ethanol made? Well, I found the moles of ethanol. Well, how many grams is that? All right, I took the moles of the ethanol right here, and this is the molar mass of C2H6O, and I got 32.7 grams of ethanol made. All right, so then what's the percent yield? Hey, the formula, that was up on top there, right? Well, here is my formula again, which is your actual that you really got. And here's your theoretical I get from stoichiometry, right? And then you have to multiply it by 100%. So what did I actually get? What is the percent yield if 26.0 grams of ethanol are what? Actually made. That's my actual. All right, now what? I have to divide it by how much did I, or should I have made? That's this number right here. This is the theoretical yield. That's what I get from stoichiometry. And then I times it by 100%, and I get 79.5%. Okay. Hopefully you did all right. So if you have any questions, jot them down and you can always ask us later, okay? Let's start with the next one, number 2. Right, so on this one, it says on a small scale, calcium can be isolated through the reaction of calcium chloride with sodium metal, as shown in the following equation. Now, this is a single replacement reaction, if you're thinking about that. And yes, sodium is higher up on the chart than calcium is. So yes, a reaction does occur, and we're going to create calcium that way. So what's the first thing you need to do? Well, hopefully you balanced it. So when I went through this, I realized I'll save sodium and calcium for the end. They're my elements. So I have 2 chlorines here. So I need to put 2 chlorines here. All right. 1 calcium, 1 calcium, 1 sodium, 2 sodium. So now I'm going to put a 2 there. All right. So now it says how many grams of calcium are produced from 7 grams of calcium chloride? All right. Well, right here, what am I supposed to do? Convert grams to moles in that box. All right. So how many moles do I have with 7 grams? Grams, periodic table. So I will put my periodic table, that's your 1 calcium or 40.08 plus 2 times 35.45, and there I go. And I put 1 mole on top. and this is how I get that. Okay, so what does that mean? Well, that's how much of calcium chloride in moles I have. Now, did they tell me anything about sodium? If not, what is that to be understood as? That's an excess. Okay, then I have 0 of these and 0 of those. All right, so if I have excess sodium, because they didn't tell me how much I have, then I assume that my calcium chloride is my limiting reactant. So I'll do this, and 0.0631 minus 0.0361 is indeed 0. All right, so ready? I'll take 0.0361, divide by 1 times 2. Well, guess what I got? That number. Well, I'll have excess remaining. Okay, now what? Over here, I have 1 calcium here, so 0.0631 divided by 1 times 1. I'm going to add that. Remember, always going to create more products. And I'll do the same thing and got a 2. Just quickly notice that these coefficients are the same. Notice that these numbers are the same. Okay, it just kind of helps you out, doesn't it? Okay, so now what? How many grams of calcium are produced? All right, so how many grams of calcium are produced? From what? From this many moles, right? So put that moles, here's your calcium column, there's your moles. I'm going to put 1 mole on the bottom, right? And if I look up calcium on the periodic table, I'll get 40.08 and I get 2.53 grams. Okay, so now what? If 2.2 grams of calcium are actually made, what's the percent yield? So percent yield is equal to actual over theoretical. Oops, that's from your Stoich, right? I'll move this up so you can see it. Theoretical from your Stoich, all right, times 100. And so that will be my actual or actually made is your 2.2 grams. Well, how much did I make from stoichiometry of calcium? Oh, that's right here. I made 2.53 grams from my stoichiometry. And then I'm going to times it by 100%, and I get 87%. Okay, so again, if you didn't get what I did, mark it down. I hope I didn't make a mistake, and we can ask, in person or on whatever the medium there is, and you can ask questions and see how we got our answers. All right, or you'd go back and try to work on it yourself. You have a calculator, periodic table, so work on it. Let's go ahead and look at the next page. All right, number 3, tungsten can be prepared from one of its minerals. What mass of water can be produced from the complete reaction of 100 grams of tungsten 6 oxide given an excess amount of hydrogen? All right, so can I put the 100 grams right here? No, Mrs. Vanderwall, you're silly. All right, I need to come up with moles. Oh, wait a minute, what should I do first? I need to balance this, right? 1 tungsten, 3 oxygens, 1 oxygen. I think I better put a 3 over here. All right. Now what? I have tungstens and hydrogen, or oxygen are good. 2 hydrogens, 6 hydrogens. So I need to put a 3 over here. Now I'm good. All right, back to the problem again. Should I put 100 grams right down here? No, it goes to moles. All right. So I need moles. All right, well, how many moles do I have? All right, I went on the periodic table and I found 1 tungsten and 3 oxygens, and I got 231.85. All right, and I put 1 mole on top, so I end up with 4 sig figs, by the way. Did you notice that? I have 4 sig figs. Why? Because I have 4 sig figs here. So that's how much I have. Now, what else did they tell me? Given and what? Excess. All right, we have excess of hydrogen. Woohoo! And I'll go ahead and put these guys in. All right, so obviously my WO3 is going to be my limiting reactant because I have excess of the other one. So 0.4313 divided by 1 times 3 is 12 or 1.294. And then if I subtract those out, I get excess. And then, well, 0.4313 divided by 1 times 1 is still 0.4313. And there I go here. And then 0.4313 divided by 1 times 3 is still 1.294. Okay, so then I add those, here I go. All right, here we go. So it says if the percent yield is 90%, it's 96%, how much is actually made? Well, how do I find percent yield? All right, percent yield is actual over theoretical, right? From stoichiometry. So I have a problem. I don't know the actual. I'm being asked to solve for that. And I don't know theoretical. Oh, I got to solve for that. I need to find grams of water that I should make. Oh, that makes sense. Okay, so here is my beginning. So here's my grams of water. I have 1.294 moles of water. So I put 1 mole on the bottom, and the molar mass is 18.02. So I get 23.32 grams that I should make. All right, so watch this. Oh, I forgot that part. So I still do not know my actual. I'm asking that how much is actually made. So I'm going to call that X. All right, so what did I make? Or excuse me, what should I make? What's my stoichiometry now? 23.32. All right, and then if I have a times 100, I get, wrong one. Hang on. I have 96%. So I need to solve for X now. What the first thing I did is I divided both sides by 100%. So it's 96% divided by 100% is 0.96. So then 23.32 times 0.96 is 22.39 grams of water. Okay. Last but not least. Okay, here we go. I have 15 grams of sodium hydroxide reacts with 46.7 grams of sulfuric acid. Well, what's the first thing I should do? Of course, is balance. I hope you did too. I saved my oxygens for the last because I have 4 oxygens here. And notice I have 1, 2, 3 hydrogens. That was my second last. So let's balance your sodiums and your sulfurs first, all right? So I have 1 sodium, 2 sodiums. So I'm going to put a 2 here. All right, I have 1 sulfur, 1 sulfur. That was easy. All right, let's do hydrogens next. I have 2 hydrogens here, and I have 2 hydrogens here. What's 2 plus 2? 4. So I need to get 4 here. All right, I'll do that. I'll put a 2 there. And let's check our oxygens. I have 2 and 4 make 6. 4 and 2 make 6. Okay, that's great. Now what? I've given grams, I'm given grams. So what should I do? I need to convert grams to moles. All right, so let's do sodium hydroxide first. So how many moles is in 15.5 grams of sodium hydroxide? All right, I looked at my periodic table, and 1 sodium plus 1 oxygen plus 1 hydrogen adds up to 40. And then that's a 1 mole. So 15.5 divided by 40 is 0.388. So what do I do with that number? I put it right here. All right, now what? I have to do my sulfuric acid, don't I? Okay, so here I go. How many moles do I have there? Well, what's the molar mass? What's 2 hydrogens plus 1 sulfur plus 4 oxygens? That adds up to 98.09. And I put 1 mole on top. And what do I get? I get 0.476, or excuse me, 476, yes. So now what? All right, I need to place that in here. All right, so here I put this here. And hey, what I know about my products, I always start with no products, don't I? Yes, I do. All right, so now what? I need to decide which is my limiting reactant. I have given finite amount of both reactants, so which one is going to run out of first? Let's try a first one, all right, and see if that makes sense. So I'm going to use this one. All right, so what's 0.388 divided by 2 times 1 is 0.194. So I subtract that to 0. All right, what kind of number am I going to get here? I'm going to get a positive number. That works, doesn't it? All right, so I have found my limiting reactant. And does that make sense? I need twice as much sodium hydroxide as I need sulfuric acid. I don't have twice as much sodium hydroxide as sulfuric acid. All right, I have less than the original amount. All right, so this is definitely going to run out first. All right, so now what? What's 0.388 divided by 2 times 1? Same number. All right, and that's what I get when I add them. And then what is 0.388 divided by 2 times 2? There we go. Get 0.388. So here I have that. Okay, so now it says answer using your BCA table. Answer the answer. So how many moles of excess reactant do I have? I may have scrolled too far down. Here it is. That's how many I have left over. All right, that's how much I have left over. So here I have it. So now what? How many grams? Remember, this is moles. How many grams do I have? All right. So how many grams of sulfuric acid do I have? 1 mole goes on the bottom. Sorry about that. The molar mass goes on the top. And I get 27.7 grams. So that's my answer, all right? So how many grams of sodium sulfate are actually produced? All right. I'm sorry. How many grams of sodium sulfate should be produced? That's what I'm really asking for. I'm asking you for the theoretical yield. All right, so here's this. 1 mole goes on the bottom. Molar mass of sodium sulfate, I got 142.05, so I get 27.6, all right? So now what? If 62.45 is actually produced, well, look at this. I'm only supposed to make 27.6. I've made 62, all right? This is huge, all right? So here's my percent yield, actual over theoretical times 100%. All right, what did I actually make? Look at that, that's in bold. All right, 62.45. What should I have made right here? 27.6. All right, and I'm then what? Times 100%, and I got 226%. And what did I write next? Oops, that can't be pure, can it? So hopefully this was helpful for you. Again, practice will help you out. And hopefully this is all it was good for you. So if you have any questions, just let us know. Take care. Don't wait to be great. Bye-bye.